I was going to do a lesson on electron configuration. So I'm going to actually screen share so you can actually see this. And this is actually in the portal already. And so, of course, if you have questions about anything, you can always come through and ask me whatever you need to ask me for help. So I'm going to actually screen share. So give me 1 second. Let me go ahead and share this out. Okay, so the worksheet that I have that's on electronic configuration, this is what it is right here. So what we're going to do as we go through the electronic configuration, make sure you got a pen, of course, your notes with you. This packet here is actually going to appear in your portal, so you can actually go back through and find it and look at it, and it'll have a lot of great information that you can actually utilize for that. So let me go ahead and change over. Okay, so this is what we're working on right here this morning, and it deals with electronic configuration. So I'm going to actually explain to you how this whole process works. And like I said before, if you have questions, please don't hesitate to let me know. For the most part, this particular unit here, it can be very confusing to a certain extent if students aren't familiar with certain processes when it comes to electron configuration. So what I'm going to do is kind of highlight some of these key points here so that you can understand everything that's going on with electronic configuration. One thing you do have to have, of course, is a periodic table, because having that periodic table will help you know where everything is located, because I'm going to actually show you certain things and certain concepts that you need to be mindful of when it comes to electronic configuration. Now, there are different things that you need to be aware of when it comes to electronic configuration. One being the groups that are outlined on the periodic table, how you're supposed to use them to your ability, okay? So when we look at the periodic table and we see that it's designed with atomic numbers on there, the atomic numbers and group numbers and periods will play a role in terms of where things are, okay? So I'm going to actually go through this now and show you how to work this out, okay? So right here, I do need to scroll. Matter of fact, let's see. I'm going to first give you a periodic table like that I'm going to actually share and walk you through, because you're going to have to understand how the periodic table is designed in order for you to understand everything that's on this purple part of the handout. Now, when it comes to electronic configuration, okay, this is something that many students aren't familiar with. And that's because some of this stuff doesn't make sense when you think about all the things you have to do in order to understand it. So right here, I'm going to highlight some things, and I always tell students to color code it so that they are aware of what they need to know for their chart, okay? So you want to color code this in order for you to know where things are located. So on the S block right here, this is over here within groups 1 and 2. So I'm going to actually make this, let me make it a little bit larger so you can see it. Okay, there we go. All right, so over here in groups 1 and 2, these are called your S blocks, okay? So right here, you have your S's. Now, what does that mean? That means that the most electrons that you will have in that sub energy level will be 2. And again, I'm going to break it all down for you in a second. It will all make sense to you once you see how I'm doing it. Now, in the middle section, and let me put this here too, and there are 2 columns as you can see, okay? So therefore, the most you will have is 2 for the S block. The next sub energy level is the D block, okay? And that's right here in the middle. And there are 10 of them. Therefore, the most electrons you'll have in the D block will be 10. Now, over here on the other side of town are your P blocks. And within your P blocks, there are 6 of them. And as you can see here, it goes from groups 13 to 18. Within that particular group, the most you will have is 6 electrons, okay? 6 of them. Now, down below, the group that was extracted from the periodic table, this is what we call the lanthanide and actinide series. There are 14 of those groups right there, okay? There are 14 of them, and the most you'll have in that group, and that sub-energy level is 14. Now, what this means is when you start writing out the electronic configuration, you've got to be mindful that when you look at the number of electrons that you have, that tells part of the story, okay? So the electrons, if you recall from earlier this week, the electrons are the atomic numbers, okay? They are the atomic numbers. Also, what you have to keep in mind is that there are 18 periods. So I'm not 18 periods, excuse me, 18 groups. It starts over here. Group 1, 2, 3 through 12 is right here in the middle. Then 13, 14, 15, 16, 17, and 18. When it comes to your groups, in terms of your valence electrons, because this is what's going to also play a factor in you determining how many valence electrons you're going to have on your sub energy levels. When you get to groups 13 through 18, you drop the 1 off. So that's going to give you 3 valence electrons for the group 13, 4 valence electrons for group 14, 5 for group 15, 6 for group 16, 7 for group 17, and 8 valence electrons for group 18. Now, just as there are 18 groups, there are 7 periods. So here they are right here. I'm going to put them in a different color so you can see that, okay? You have period number 1, which consists of hydrogen and helium. So periods go across. Period 2 consists of lithium, beryllium, all the way to neon. Period 3 begins with sodium and it ends with argon. Period 4 begins with potassium and it ends with krypton. 5, 6, and 7. So it continues with that process. Now, these 2 groups right here, if we were to insert them back into the periodic table in its respective manner, we would notice that we would end up with putting them in as a part of period 6 and 7. Excuse me, okay? They would be a part of periods 6 and 7. Now, what this also means is that there are certain little tricks, certain little key factors here that you need to remember so that electronic configuration doesn't have to be a hard thing to think about, okay? So we're going to take our time with this morning. And if you have questions, of course, let me know in the chat box. YouTube, you let me know in the chat. TikTok, you all let me know in the chat as well. Now, with chemistry, as we've talked about before, we've said over and over and over, when they say periodic table, period means things that happen ever so often. As you all know, there's an old phrase that says, the clock can be right 2 times a day. You know, so if the clock is broke, a broke clock works twice a day. You know, it's going to tell the time, the same time, twice a day. Okay. So that means things happen ever so often. And you have to look for trends of the periodic table so that you know how all of this works. Okay, so again, what I wrote in blue, for those of you all that are coming in now, what I wrote in blue, those are the sub-energy levels, S, D, P, and F. What I wrote in yellow are the group numbers, But when we drop the 1 for groups 13 through 18, like 3, 4, 5, 6, 7, 8, those give you the valence electrons that plays a role in this as well. And then what I wrote in green highlights the number of periods that you have. Okay? So what we're going to do is show you all some other tips and tricks that you can use in order to understand all of this, okay? So I'm going to switch my screen out for a second and let you all see this other piece here, all right? So what you see, you should see a purple screen, all right? And within that purple screen, you should also notice that there are things here, particularly section 2, okay, right here, where it says the periodic table is an excellent guide to filling orbitals. So I'm going to walk you through that part as well, okay? I'm going to walk you through that as well. Now, for this part right here, as I mentioned before, the S block, S as in Sam, are the first 2 groups, okay? The first 2 groups plus helium. Group 1 and group 2. When you look at the P block, that's groups 13 to 18. That's the right side of the periodic table. And there are 6 columns of that. The D block, that's your transition metals. They're right there in the middle. And then the F block, those are the lanthanide and actinide series of elements. And they're right there at the very bottom that were extracted from the periodic table to make it appear smaller. When I say on the S block that you have up to 2 electrons, this is what we're talking about right here, okay? So on the S block, the most you can have is 2. The D block, the most you can have is 10. The P block, the most you can have is 6. And the F block, the most you can have is 14. Watch what happens when I go back to that periodic table to show you what we mean by the periods, okay? Because when you look at it, here's your tip. Each period or row in the periodic table tells you the energy level of the orbitals you are filling. I'm going to say that again. Each period or row in the periodic table tells you the energy level of the orbitals you are filling. So I'm going to go back to the periodic table so you can see what I mean by that, okay? So that you all can kind of walk me through it together. So you can walk with me together on this process. So right here, okay, as you will notice, when we say the first period has S energy levels right here, S sub energy levels, okay? You see this part right here that I'm going to highlight. Matter of fact, I'm going to put a yellow, I'm covering up the S2 right here. Now that looks like it's green up there, okay? On the first period, we have S's, okay? That's what we have on the first period. We have S's. Now, when I look at the second energy level, and I'm going to highlight that in pink so you all can see this, okay? When I say the second energy level, you see how I'm coloring lithium and beryllium all the way to boron, all the way to neon? Guess what? On the S, or on the second energy level, you are coloring S's and P's. S's and P's. Okay? You have S's and P's that your energy levels are consisting of. Now, when you look at the third period from sodium, magnesium, all the way over here to argon, you still have S's and P's, okay? But then you're going to have a D in there as well. And that comes up once you skip down here to the fourth energy level. Now, on the fourth energy level, you will have S's, D's, and P's, okay? Again, I know sometimes students are like, what? What in the world are you talking about? Electron configuration just simply tells us basically the social security number of that element, okay? That's pretty much what it is. It tells us the social security number for that element. All right. If you are understanding so far what I'm saying, give me a thumbs up in the chat, okay? If you're following me with what I'm saying, give me a thumbs up in the chat. If you're like, wait a minute, say that one more time, then give me a confused face in the chat. If this is like, what in the world? Give me a confused face in the chat if that's you. But if you understanding it, give me thumbs up. Okay, hey Tabby, good, 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 good. Okay, she means business is like, okay, I'm thinking. Okay. All right, so let me go ahead and share this with you all again, okay? Once we start to do them, it'll all make sense eventually, okay? Now, I just mentioned this part right here about the S's having 2 electrons, the maximum, the P's having 6, the D's having 10, the F's having 14. Okay, based on what I said there, let me show you this next part. We're going to skip this part about some of these other rules, but here's the one main thing that I want you all to see right here, and that is the order that you have to do them, that you have to write out the electronic configuration, okay? So I'm going to explain this part to you in detail. All right. Right here, you will notice where it says 1s. Then there's 2s and 2p. Then there's 3s, 3p, 3d. Then there's 4s, 4p, 4d, 4s. Okay, all of this is telling you these are the orders that you're going to write your configuration. Now, right here, okay, I'm going to highlight it for you so you all can see. This section right here, that tells you the sub energy levels. But then what I'm circling right here, number 2, this is the correct order. You're going to start with 1s, fill that in, then go to 2s, then go to 2p, then 3s, then 3p. Now, again, that's the order that you go in. Now, to make this make sense, because I know you're like, oh, Lord, can you do one so I can see what you're saying? I sure will. I sure will. So let me go ahead and give you all one that we're going to do, okay, so that you all can follow, all right? Practice makes perfect. Okay, so I'm going to scroll. What I'm doing is I'm scrolling on my notes here, okay? Because this is the section right here where you always do this. So we're getting ready to do an example for you so you can see exactly what we're talking about, okay? All right, good job over there on YouTube. Good job. This question says, how many electrons does the element have? So these are the 3 things you need to ask yourself, okay? When you're doing electronic configuration. Number 1, how many electrons does the element have? That's the first question. Number 2, what block is the element located in? What block is the element located in? And then question 3, what energy level is the element located in? What energy level is the element located in? All right, so let's take a look at a few examples here so that you all can see exactly what I'm saying, okay? So we're going to first look at just a few, all right, so that you all can see how this process works. We're going to practice. So here's your periodic table right here, guys, okay? Here it is right here. All right, so first, let's do this. Let's take a look at hydrogen, okay? Hydrogen. What block? Well, first off, how many electrons does hydrogen have? And I'm going to write this off to the side over here so that I can use some of this space, okay? So hydrogen, we're looking at hydrogen first. How many electrons does hydrogen have? It has one electron, one electron. My next question is, what block is hydrogen in? It's in the S block. It's right there. You see that? It's in the S block. And which one of the S blocks? It's in the very first one. That's where that one comes from. So guess what we're going to write for the electronic configuration? Hello, Anonymous. Thank you so much. So what you're going to write is 1s1 for hydrogen. Okay? That's it. 1s1 for hydrogen. All right. Now, we're going to do the next one, okay? We're going to do the next one. Let's take a look over here at helium, okay? Take a look at helium. Helium has how many electrons? Hey, Tabby, what I'm going to do, I'll go through some of those as we practice more and more. Yes, I'm going to go through chromium and copper. And because I'm glad you brought those up, they actually have exceptions to the rules. So yes, so we will get to that in a moment. But thank you so much for asking about those. Yes. And I like your name. My first name, people used to call me Tabby when I was younger. Oh, for sure. Or Tabitha. I didn't like Tabitha. I didn't want to be called Tabitha. Oh, so as we look at, yes, hey, TJ, yes, we're doing electronic configuration. When we look at helium, helium has two electrons, right? You see helium right here? I'm going to circle it. Here's helium. Now, what block is helium in? Is it in the S block, P block, D block, or the F block? Well, from my eyes, I see it in the P block, but guess what? P's are only based on period 2 and above, okay? So technically speaking, even though it's on the P side, if you all recall what I just said, the only two elements that are in the S blocks are hydrogen and helium. Oh, how did I get two? Helium has two electrons. So the first question that we're asking is, how many electrons does helium have? And there are two. The atomic number that's in that upper left-hand corner represents 2. Now, it's a part of the S block, and because helium has 2 electrons, we're going to put a 2 right there for helium. So you know what we're going to write out for our electronic configuration? Oh, one thing too you need to know is what period is it in? It's in period 1. So when I write all this out, guess what I'm going to put together? 1s2. And guess what? This 2 right here indicates the total number of electrons I have for helium. Okay? That's what it indicates. This tells me the number of electrons I have for helium. And this is the total electron configuration for helium. Now, we're going to keep practicing so that you guys can see the pattern that occurs with these examples, okay? So we're going to continue with the pattern so you all can see the process. Y'all, when I used to do this back in undergrad many moons ago, my professors made this so difficult. I did not understand it at first, but now, of course, I get it. Here again, as we practice, take your time. Let's look at lithium. Lithium right here, okay? I'm coloring it right here. You see that? I just put a little dot over lithium. Lithium has 3 electrons. 3 electrons. Lithium is in the second period. You see that 2 beside lithium? It's in the second period. Lithium also is a part of the S block. S as in Sam. It's in the S block. It's in the first one at that. So you know what I'm going to write down for my electronic configuration? The first thing is 1s2, then 2s1. And when you add up the 2 and the 1, you get the 3 electrons right here for lithium. Okay? All right. Okay, now, again, yes, I agree. The best way to do it is to color code your periodic table. I totally agree with that. And I tell students that all the time. Now, because I am switching from screen to screen, you guys bear with me because I'm going to show you where I got the 1s part from, okay? Yes, thank you, Anonymous. Thank you. So let me go back over here, okay, so that you all can see exactly what I mean about where did I get the 1s2 from? I'm going to show you. All right, right here, I got the 1s from the order that you have to do your configuration, okay? So you remember when I said there's a certain order that you have to fill it in? This is it right here, okay? This is it right here. So whenever you do electronic configuration, you've got to start off with 1s. So like if I ask you, what is your social security number? You're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9. You wouldn't say 9876 5, 4, 3, 2, 1. You wouldn't do it that way. You would go in the order that you say your number is, okay? So the electronic configuration is basically the social security number for that element. So the order that I have to write this in is 1s. Fill that up with the 2 electrons. 2s. Fill that up with 2 electrons. 2p. Fill that up with the maximum of 6. When you go in that order, everything will start to make sense. Okay? Everything will start to make sense. When you're looking at this for the first time, I promise you it does look confusing, but this is where the practice is. Yes, thank you. You're welcome. Yes, it's the social security number for that element, okay? So if I ask you, and I wish I could put the periodic table right here, side by side, but I don't have space for it, but I'm going to pop it up here again so that you guys can see it. When I ask you these questions over here on the left-hand side of my screen, that is so that you all will know the order in which you would write out your configuration. So let me show you another one. I'm going to show you this right here, okay? Here we go. Let's take a look at beryllium, which is right next door, okay? Beryllium is right next to lithium. Beryllium has 4 electrons. 4 electrons. What period is beryllium in? It's in the second period. See that 2, that green 2 right there? It's in the second period. What block is it in? It's in the S block. You see that green S up above? That's the S side. So if you look at this periodic table, you see that I have S, D, P, F. Those are like zip codes or neighborhoods. If I say what neighborhood is beryllium in, you're going to say, oh, it's in the S neighborhood. If I say what neighborhood is iron in, you're going to say, oh, it's in the D neighborhood. If I ask you what neighborhood is boron in, you're going to say it's in the P neighborhood. So those are like neighborhoods, okay, for these elements. So beryllium is in the S neighborhood. But which part of the neighborhood? It's in the second one, okay? See that 2 above it? It's in the second one, okay? Well, it's only 2 columns. It's either the first or the second one. Now, if I ask you, all right, give me the electronic configuration, guess what you're going to do? You're going to first start off with 1s2, then 2s2. And by the way, this stuff right here that I'm highlighting in pink, that's the last thing you would write for your electron configuration. Okay? That's the last thing you would write for your electron configuration. So now, if you add up what I'm going to show you now in yellow, these two little yellow twos right here, 2 plus 2 gives you 4 electrons. And voila, there it is right there. Okay? That's how you get the electronic configuration for these elements. All right. Let's pick one. Let's look at oxygen, y'all. Let's pick one from the P neighborhood. All right. You see these columns right here, right? There's one, and I'm going to highlight this for you in green. This is the first column for the P, second column, third, fourth, fifth, and the sixth one. Okay, watch this. If I ask you, okay, to tell me, we're looking at oxygen, okay? Oxygen. I'm going to circle it so you all can see it. Here's oxygen right here. Oxygen, okay, has 8 electrons. It has 8 electrons. What period is oxygen in? It's in the second period. You see that green 2 and you slide on over? It's in period 2. What block, what neighborhood is it in? It's in the P neighborhood. And which part of the P's is it located in? It's in the fourth one. If you count over 1, 2, 3, 4, it's in the fourth one. So now, what are we going to write? If we go back to that order that you're going to write your electronic configuration in, okay? It starts off with 1s first, okay? So that's 1s2, 2s2, 2p4. All right. You see this 2p4 right here that I just wrote? That's the last thing you would write for your configuration. And guess what? If you add the 4 plus the 2 plus this other 2 right here, you're going to get a total of 8 electrons, which is the number of electrons for this oxygen atom. All right. Anybody have any questions so far in the chat? How's everybody feeling right now? I want to make sure you're good before I continue. Okay? I want to make sure that you guys are good. Because I know sometimes when students are looking at this, it's like a roller coaster ride. It's like either you get it or you don't, and it just takes practice. But I have patience. So, if you don't understand, we can go through it. We can continue. I wanted to do the easier ones first before we moved on to some of the more advanced ones, because if you don't understand the easier ones, then you're going to have a problem. Jamal, what do you mean? All right. Now, let's take a look. Let's go to the third period, okay? The third period. We've got sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Those are all of our elements in the third period. Now, because they're in the third period, that means after we get through with the second energy level, we're going to head on to the third energy level. And again, for those of you all that may have forgotten, or you just stepped in, let me go back to my reference here on my the purple handout that you guys just saw me put up, okay? So let's go back to the purple handout. So right here, okay, right there, as you see in the purple part of the handout, this is the order that you're going to have to go by, okay? Again, you've got 1S. Once you fill that up with 2, you're going to move to the 2S section. The most you can fill up is 2 there. Then you're going to go to the 2P section. The maximum you will fill up is 6. And if you think about what's on the periodic table, in terms of the order, the maximums are the numbers that you see here. S's can hold up to 2, P's can hold up to 6, D's can hold up to 10, F's can hold up to 14. So now I'm going to go to one of the third energy level groups so that you all can see exactly what I mean by this, okay? So because we're going to the third energy level right here, that means we're going to be dealing with 3S something, 3P something, okay? So keep this in mind. Keep this in mind. All right. Now, I'm going to go back to my periodic table so you all can see this, okay? Here's the periodic table right here. Okay? We're going to pick, let's do chlorine, okay? Chlorine. I'm circling chlorine in blue. See that? I circled chlorine in blue. Now, what are we going to do? We're going to first ask ourselves, how many electrons does chlorine have? Okay? How many electrons does chlorine have? So now I'm going to have to write really small here. Okay. Chlorine has 17 electrons. Chlorine has 17 electrons. Very good, she means business. Very good. 17 electrons. My next question, what period is chlorine in? Look at the periodic table and tell me, what period is chlorine in? So if you look right here, oh, good, 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 good. MGLR, very good. Good, Tabby. Good, Leslie. Right. So it's in the third period. Now, what neighborhood is it in? Is it in neighborhood S, P, D, or F? What neighborhood is chlorine in? Good job, Tabby. Right. It's in the P block. Yep. Which one? Which house is it in? The first house, second, third, fourth, fifth, or sixth? 5. That's right. It's in the 5th house in the P block neighborhood. Okay. You guys see it? So guess what? The last thing we are going to write in our configuration or our social security number of the element is 3P5. That's the last thing we would write. So to give me some space, I'm going to go down below right here. To give me some space, I'm going to write it down here. Okay. So the first thing I'm going to write is 1s2, 2s2, 2p6, 3s2, and the last thing I wrote was 3p5. Okay, remember the order is based on what I showed you on that purple handout, okay? The order that you fill them in was on that purple handout, okay? Right there. Okay, that's the order. 1s, 2s, 2p, 3s, 3p, okay? That's the order. Now, if you want to check yourself to make sure that you did it right, what you have to do is add up those little superscript numbers, okay? Add them up. So when you add up your superscripts, okay, you're going to end up with 2 plus 2 plus 6 is 10. Plus 2 is 12. plus 5 is 17. 17 electrons for chlorine, and there you have it. Good job, Kelly, over on YouTube. Good job. Good, she means business. I'm glad you got it. I'm glad you got it. Glad you got it. All right. Now, I know it would require you all to do a lot to write this out. So here's what I'm going to do. I am going to give you all a multiple choice problem to do with this to see if you all can figure this out right here. Okay. And let's see what we get from here. Hold on, not that one. Let me see. Okay. Without y'all seeing the answers, because I'm over here multitasking. Okay, so here's one of your practice problems right here. This is for sulfur. Okay, so I know you all can't see where sulfur is, but let me give you all a tip. If this was one of your problems that your teachers told you to do, right? If this was on your test, what is the easiest thing that you could do to get the answer? To get the answer, if this was a multiple choice test question, to get the answer, good job. That's right, Tabby. Count the superscripts. That's right. Count the superscripts. Hey, Lakia, that's right. Count the superscripts. And if it adds up to the atomic number, okay, then get that and keep it moving. So which one of these answers over here has 16 electrons? Okay, so I see several of you all put A. And you are correct. If you look at some of these other answer choices, like let's look at letter B. Letter B, they have filled P. So we know that's not even right. So we got to discount letter B. Letter C, it doesn't even add up to 16. It only goes up to 14. So we got to discount that one as well. And then when we look at letter D, well, that's too many. That goes up to 18. So if you look at the answer choices, adding them up will give you the right answer. Okay? So again, when I say you all should not make this difficult, that's exactly what I mean. Do not make this difficult. Okay? So now I'm going to give you all another one. Let's see here. Oh, I've got a good one where I'm going to give you the let's see here. Where I'm going to give you you have to read the question and see what I'm asking you to do, okay? So here's what you've got. It says, what is the electron configuration of an element in group 14, period 3? Group 14, period 3. Okay. Here's how you can think about this. If they told you it's in period 3, well, the last thing that you're going to write, of course, is 3p. So pretty much any of these could be the right answer. But what you need to do is go to your periodic table and find group 14 and then period 3. So let me show you what we're going to do, okay? So some of you all have a periodic table in front of you. So I'm going to show you all again how to do it based on the given information that I just stated, okay? So I said group 14. So let's find group 14. I'm gonna circle group 14 in red. Here's group 14, but they said period 3. So here's period 3. Here's group 14, and voila, right there, it smacks dab right there at silicon, which has 14 electrons. 14 electrons. So again, I found group 14, which was right here. Group 14 was right there. And period 3, I just kind of scrolled them over, and then they merged right there together. They merged right there together. So guess what that means if we were to look at our answer choices. Because silicon has 14 electrons, what you now have to do is go down here and count the elements, or excuse me, the configuration that has 14 electrons. Okay, so to start you guys off, we know that the first 6 right here, I'm sorry, the first 3 that you see right here equals to 10, okay? So all of these equal 10, A, B, C, D. The first set equals 10 right here. But you've got to go up to 14 electrons. So I see several of you all said letter A, and let's see if you guys are correct. 2 plus 2, that does give you 14. And so, yes, letter A is the correct answer. Very good, very good, very good. All right. Any questions from anybody so far? I know you want to do one of those that is like, I would say a little challenge. So we're going to do that too. Okay. Oh, so Tabby had asked me earlier about electron configurations for copper and what was the other one? Copper, and it was the one that was in the middle. Okay. So let me go ahead and go there now. So I can explain the rule to understand why it is what it is, okay? So here are some exceptions to the rules. I actually have a screenshot on my on TikTok. So if you all go and look for electronic configuration on my playlist, you will actually see the screenshot for those that you have to memorize, or I mean, I would say not memorize, but maybe look at the pattern. But let me show you all something right here with this configuration. When you get into the middle section, the D blocks, okay? The Ds have issues to a certain extent, all right? But let me tell you why. They don't get filled up. Well, there are 2 of them that are like that. Let me scroll down here. So you all will know what they are. Well, I had them. Hold on, y'all. There are 2 that are the exceptions. Trying to find it in my notes. Oh, here they are, right here. This is on page 8 of my guide right here, okay? If you all want access to these guides, I have a membership that you all can join, and it's only $19 a month. And with that $19, you get access to all of my video recordings edited. So you don't hear all this extra talking. It's actually edited, and I actually give you all more worksheets than what I do on the live, okay? So if you all wanted these worksheets, you can get access to them, okay? Just send me a DM and I'll give you the, or you can actually go up to my profile and it'll be right there. Now, these are the exceptions to the rules. D blocks, elements like chromium and copper prefer a half-filled or fully filled d orbital to gain stability. So when you look at copper and chromium, those don't follow the trend per se. in terms of the Ds, okay? Whoops. So right here, make sure that you are aware of this. Copper, okay, and chromium are the ones that get half filled. So instead of saying 4s2 3d4, the 4s is half filled. The 3d gets filled up, okay? So if you just remember those two, you don't have to worry yourself in terms of knowing if you've written it out properly. So let's do some practice problems with the D blocks so you can see what I mean by that, okay? Let's practice with the D blocks. All right, so of course I'm going to have to trade over to my other periodic table, okay? And what you see here also in brackets, the argon that's in brackets, this is called the noble gas configuration, but we'll do the noble gas configuration for later, okay? We'll talk about that later on. But I'm going to go ahead and show you how to do the configuration for the D block elements. All right, so let's go back here to our periodic table because we do need that for this next part. Okay, so right here. And I'm going to erase a lot of this stuff so you all don't have all this extra stuff that you're looking at. Excuse me. Okay, let's look at the first one that's there. Let's look at scandium. Right there. It's part of the D block. Okay, see that? That's scandium. So here's what we're going to write for scandium. First question is, how many electrons does scandium have? It has 21 electrons. 21. Next question, what period is it in? Well, I see the fourth period. It's in the fourth period. What neighborhood, meaning block, is it in? What neighborhood, meaning block, is it in? Now, I'm going to put that down here, not beside the 4, but I'm going to put it down here, the D block. That's right. And which one? The first one. Now, the reason why I did not put the D beside the 4 is because of the pattern in which you're going to have to write this out, okay? Follow me. Walk with me. We're going to walk down this road together. Matter of fact, let me show you the road we're going down together. Okay, I'm going to go back to this part right here. Okay. All right. So you see this chart, right? You see this chart. This chart tells you the order that you're going to go. You're going to say, after you get out of the 3p, when you get to the fourth energy level, yes, you're going to say 4p right here, but then you're going to go to 3D right there, okay? So it's 1s, 2s, 2p, 3s, like the pattern continues that way, okay? So 1s, 2s, 2p, 3s, 3p, 4s, 3d, okay? So let's fill that in. Matter of fact, we'll do it right here so you all can see how that works. We told you that scandium has 21 electrons. We said that it was in the fourth period, but we also said it was in the D block, okay? It was in the first one. So we're going to write out our configuration for this right here. We're going to say, and by the way, guys, I also tell my students, whenever they're doing electronic configuration, if they write out the format, they can start to deduct from it. Okay, and I'll explain what I mean by that in a second. So I'm gonna table that in a second. Okay, I'm gonna come back to that thought. So right here, I'm gonna write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now I'm gonna stop right there. Let's add all these up for what we have so far, okay? We've got, whoop, hold on, y'all. Okay, if we add these up right here, we've got 2 plus 2 plus 6 gives us 10. Plus 2 gives us 12. Plus 2 gives us 18. Plus 2 gives us 20. The last thing we're going to write is 3D5 right there. 3D5. And that's because not 3D5, I'm sorry, 3D1. 3D1. The last thing we're going to write is 3D1 because D1 was the last thing that we know that element is located in. It's in the D block, it's in the first one, and that's where the 3D comes from. Although it was in the fourth period, it was a part of the 3D, but it's in the 3D1 section. So after the 4S, you then go to 3D, and there you have it, 3D1. Okay? All right, is this making better sense now than when you first walked in the door? Y'all know we got to do another one to make sure you're good. We're going to do a couple more to make sure you're good. Hey, Margaret, I'm glad you're in here. Yes, I'm glad you're here. This does not have to be difficult. It doesn't. But unfortunately, some of my colleagues make this so hard. Trust me, I get it. Okay. Now, I'm going to erase this, okay? But let me tell you what I was saying earlier. When I said I'm going to table that thought and come back to it. Okay. There is a pattern. If you know that this is the configuration, I might have it on this guide so that you all can see it. If you know that the pattern is 1s2, 2s2, 2p6, all of that, what you can also do, no, it's not on here, but what you can also do, y'all, you can just kind of like subtract from that or deduct from it. So let me break it down further, okay? So you can see what I'm talking about. All right. So earlier, when I was telling you all that this was like the configuration for right here. Okay, so let me get some space right here. I'm gonna write it, I'm gonna paste it right here. So if you see right here where I have, I'm gonna write this out so you all can see what I mean. Okay, and I'm gonna expand this so you all can see it. And I'm gonna break this down for you. If you know, if this is like your basic configuration, right? What you can do, like if I ask you, give the electronic configuration for an element, you can just use this as a guide and just subtract from it. So I'm gonna pull the periodic table down so you can pick up what I'm putting down, okay? So here it is right here. If I tell you to do let's look at nickel. Nickel is right here, okay? Number 28 has atomic number 28. All right. Nickel has 28 electrons. Okay. Another way that you can do this problem, instead of saying what period is it in with all that other good stuff, if you know that nickel has 28 electrons, what you can do is count up to 28. So I already know that this first part right here, up to 4s2, that gives me at least 20 of my electrons. How many more do I need in the D block? Instead of those 10, how many more do I need in my D block? Put it in the comment box. How many more do I need in my D block? Yep. Ladybug got it right. Tabby got it right. Yes, you need 8 more. So instead of writing 3D10, you're going to write 3D8. And voila, that is your electronic configuration for nickel. Okay? So you can do it two ways. You can either write down, good job, Kelly. You can do it either this way, where you can just write out the whole configuration and then start deducting from it, or you do it the other way that I showed you at the very beginning of this class. Okay? Now, remember I said there are exceptions to the rules. Who can remember, who can tell me what those two elements are? If you can remember, write that in the chat box. Which elements are the exceptions to the half energy field rule right here for the yes, good job, Tabby. Copper and chromium. So if we look, let's go ahead and look at that. Okay, let me pull the periodic table down again so you can see that. Okay, right here. And that matter of fact, copper is right beside nickel. Okay, it's right beside nickel. So I'm going to circle copper. Copper has 29 electrons. 29 electrons. But remember, the rule says that because copper has 29 electrons and it is half filled, okay? That means instead of saying 4s2, you will not fill that. You're going to only say 4s1, and then whatever the difference is, you're going to put that there for the 3D. So you're going to still, okay, so if we add up 2 plus 2 plus 6 plus 2 plus 6, we get 18. Plus this 1, that gives us 19. So right here, how many more do we need for the 3Ds? We need those 10 right there. Okay? Oh, whoa. Hold on. I don't count it too far. Or did I? Hold on. Let me make sure. Yeah, 29. Yeah. I'm moving fast. Okay. So if we got, yes. So we're going to end up putting right here, we're going to get our electronic configuration, okay? So we're going to end up saying, since we have 10 more that we need, we've got 2 plus 2 plus 6 is 10, plus 2, 18, plus the 6 right here. I'm sorry, that's 12, plus the 2 right here is 18, 19, and then right here, okay? So what we're going to write down for our configuration, I'm going to say 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Now I'm going to pause right there for a moment. How many do you see right here? Okay. Then you're going to put your difference right there. All right. So I'm gonna let y'all marinate on that for a moment. Okay. Anybody have any questions? Any questions before we finish? Any questions? Okay. Do you all want to do one more? Do you want to do one more? We haven't done an okay, Chrissy MX. Okay, all right, Ladybug. Yep. Yeah, something harder. Listen, it don't have to be hard, right? See, all this makes sense. Yes, it all makes sense. Again, practicing will get you what you need. Okay, so let's choose another one. Well, you know what? Let me show y'all the noble gas configuration too, real quick. Noble gas configuration just simply means okay, let me go to the periodic table so you can see what I'm talking about. Noble gas configuration just simply means to take the noble gas that comes before it and put that in brackets, and it takes up that amount. So if I told you to write the noble gas configuration for copper, what noble gas is above copper? The noble gas that's above copper. Well, from what I see, it's argon, okay? Argon, that's right. Good job, Lily. Argon is above copper. All right. Now, what we're going to do, and how many electrons does copper have? Does argon have? It has 18 of those. So what we're going to do, let me scroll back down right here. Yeah, even though I erased it, okay. What we're going to do, the configuration was 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, whoops, 3d10. Okay, so what we're going to do, because I was getting cut off part of my stuff, 3d10. So what we're going to do, since it takes up 18 of those, I'm going to underline 18 of those right here, okay? Instead of me writing all of this down right here, instead of me writing all of that part right there, okay? Instead of me writing all that down, I'm going to put that in brackets. That's going to be argon, AR, and then you're going to write what's left over. 4s1, 3d10. That's like you know how we text and we say OTW, on the way, or LMAO, laughing my ass off. Well, that's the same thing here. This is like the abbreviated, this is the text version of electron configuration. Okay. This is like the text version, the shorthand version of electron configuration. All right. So let's do one like that. We'll do some more. Then we'll do one of the more challenging ones. Okay. So now here's what I need y'all to do for me. Can y'all run those hearts up to 10,000 while I'm preparing you all for one of the big ones? Okay. With everybody in the room, I need y'all to run the hearts up to 10,000 to show your appreciation. In my Tupac voice, you are appreciated. Okay. So run those hearts up to 10,000. And then I'm going to actually pull one for you. Okay. So, and I'm in a good mood right now. So let's see. We're going to play a song like to keep y'all going. Okay. By the time I'm going to give y'all 60 seconds to run them hearts. Okay, this is like the intermission. So let me go ahead and grab the problem. And I forgot on the YouTube streets can't play music, so I forgot. I gotta pause that. Okay. Well, you can, but they be acting funny at times. Okay. So everybody's sweating now. So y'all got it there. Okay. Let's do the noble gas configuration for aluminum. Okay. We're going to do noble gas configuration for aluminum, and then we're going to go ahead and do one of the more challenging problems, like Tabby said. Okay. So let's do the configuration for aluminum. Aluminum has 13 electrons, right? 13 electrons. So the noble gas that comes before it is neon. Okay, so I just told you a couple of things. I just told you a couple of things that neon is taking up 10 of those. So for aluminum, instead of saying 1s2, 2s2, 2p6, 3s2, 3p1, what am I going to write? Okay, and remember, the noble gas that comes before it is neon, and it's taking up 10 of those electrons. You all write in the brackets, write in the description box, write in the chat what your configuration is going to be, the noble gas configuration for this one. Okay, y'all got it? I don't see anybody writing anything. I just wrote the configuration, but I need y'all to write out the noble gas configuration. So see if you can type the noble gas configuration in the comment box. I gave you 2 hints. And thank you all, everybody that's followed or has followed my page or following me here. I appreciate y'all more than y'all will know. Thank you guys so much for the follows and the shares. I appreciate you guys. I just need the answer, y'all, for this last one. We at 9,700 hearts, almost at 10,000. Okay, let's see if we can get this answer here. Let's see. I know Tabby got it. I know She Means Business got it. Lily, I think you got it too. Come on, y'all. Let's go. Let's get it. Y'all want me to do it. Okay, I see. That's what it is. Y'all want me to do it. All right. So the first 10 of these are going to take over neon. So that's neon. Then we're going to write 3s2, 3p1. And that is your noble gas configuration for aluminum. All right. So are we done today, guys? Or do y'all said y'all wanted some more, but nobody gave me the answer for the last one. So I'm taking that as y'all are done. Okay. Okay, you typed the answer. Hey, Axel, I didn't see your answer. Oh, hey, She Means Business. Yeah, okay, I got you, honey. I got you. You're welcome. Okay, nope. Look, I don't want you driving and texting, okay? Mm-mm. No, ma'am. Okay, so yes, you all should have written out neon in brackets 3S2, 3P1. You're welcome, Chrissy. All right, guys. Well, are there any other questions before we finish? Are there any other questions, guys, before we conclude this? Yes, the blue part. Yep, Ladybug, the blue part is the answer. Yes, the noble gas configuration. What is written in red is the long form. Short form is in blue. Yes, short form is in blue. Yes, that's correct, Axel. That is correct. Yes, it's like what I said before. It's like the texting. You know how we say OTW on the way? LOL, laugh out loud, instead of writing out the exact, like LAUGHOUT, instead of writing all that out, we're just abbreviating it. Well, this is the same thing here for the noble gas configuration. What's in blue? Yes. All right, guys. Well, on that note, okay, good. I'm glad this makes sense for you. Thank you, thank you, thank you. Well, you know what? Tomorrow is Friday. Friday, I normally play games. I would love to do experiments, but tickety tock tock, be thinking I'd be doing something. So we might try some experiments, just for the fun of it. In my area, we got snow, and so the kids were out of school. So if you have children tomorrow, I'm gonna see if we can bring the experiments on anyway. But if I don't get a chance to do experiments, we will be playing some games. I've done Kahoot, where it's really fun because the students are able to, participate and see how much they know from what we've covered for the week. So on Friday, we will be back in here to do some games. Make sure you guys tell a friend that Professor TK the Chemist is live Monday through Thursday at 10 a.m. Eastern Standard Time. And I do go on in the evening time. The times at night just vary. It's between 7 and 8. I tutor General Chemistry 1 and General Chemistry 2. I don't do organic. I don't do P-Chem. I don't do analytical. I don't do inorganic. I do General Chemistry 1 and 2. All right, guys. Well, you all have a wonderful rest of your day on purpose. Make sure that you guys stay safe out there and don't let anyone lower your aura just because they aren't where they need to be. Some people are going through things and don't want to be in the raft of their irritation. So you do an about face and go the other way. When you see people wilding out, you go opposite, okay? So if anybody needs further help, make sure you all say on my last video what you needed help on. Hold on, y'all. All right. Oh, you a senior chemistry major. Well, congratulations, Axel. Yes, P-Chem. You must be taking P-Chem now. You and congratulations on when do you graduate? Are you graduating in the spring or in the fall? YouTube, I will talk to you guys later. Chrissy, okay, what do you need help with, Chrissy? Let me know. What do you need help with? Because I know a lot of times students do have trouble, and it's like, you gotta say, look, as we say something. If you're in trouble, say something. Everything? Okay. Well, you can always book a one-on-one session with me too. Okay, you could do that as well.